Hey guys, today's video is going to be fairly straightforward. We're covering arithmetic operators and how to use them. Now I'm sure you'll be familiar with the majority of the ones covered here today, but there's no harm in recapping what you already know. So, a common use for computers is doing calculations, whether it be handling complex equations or something as simple as working out what year someone's born. To do these things, we use arithmetic operators, which is basically a fancy way of saying stuff like adding or subtracting. So let's go through some of these operations. We'll make a start with the most basic ones first. Now, I'm sure you're all familiar with addition. All it is taking the sum of the values being added. So for example, 15 plus 6 equals 21. Next up, we have subtraction. When subtracting values, you're just working out the difference between the numbers. So in this case, 64 minus 4 equals 60. Now the important thing to remember when we're multiplying is that we say the return value of a calculation is called the product. So the product of 3 times 3 is 9, and multiplication is usually denoted in programming languages with an asterisk. Now let's move on to some slightly more computer sciencey operators. As we learned in the last video on data types, a real or float is a number that has a decimal point. Real or float division means that when we divide a number, both the quotient, which is the whole number, and the remainder are returned. So in this case, 10 real divided by 5 gives us 2, and 7 real divided by 2 gives us 3.5. For those who haven't seen the last video on data types and are interested in seeing what they're all about, I'll put a link in the description. Integer division is denoted with a backslash or div. For example, 15 divided by 5 can be written in both of these ways. Unlike real or floating division, integer division doesn't return whole numbers with a decimal, instead just returning the whole number part of a division. For example, 12 divided by 8 if we were using real division would give us an answer of 1.5, but using integer division gives us an answer of 1 because it ignores the decimal. Next up we have the modulus function. Modulus is super useful and allows us to return only the remainder of an integer division. We refer to modulus as mod, however some programming languages will use a percent sign to denote modulus. So for example, 12 modulus 8 will give us an answer of 4. Why 4 do you ask? Well, 8 goes into 12 once, and the leftover between 8 and 12 is 4, and that gives us our answer. Now you might be wondering where this could be useful, but we can actually use modulus in a lot of ways. An example might be that we might only want to run a chunk of code if, let's say, someone's age is a multiple of 2. We can use the modulus function, and we know that if the result is 0, then the age divides perfectly by 2 because there's no remainder on the integer division. So we know that the age must be a multiple of 2, and therefore we can run our next chunk of code. Next up, we have exponentiation. It's denoted with a little arrow that means we're raising a number to the power, which is also called the exponent. When you're performing exponentiation in code, you'll be using the little arrow, but you'll likely see an exponent written on paper like this, where the exponent is a smaller number above the value that you want to perform the exponentiation on. So, 4 to the power of 2 is of course 16, and just to give another example, we'll do 4 to the power of 5, which of course is 4 times 4 times 4 times 4 times 4, and that gives us an answer of 1024. Rounding limits the degree of accuracy for a value. So let's take, for example, 3.14159. We round that up to 3 significant figures and we get 3.14. Not all languages handle rounding in the same way though. For example, we might see the number 6.145. If we were rounding that to 3 significant figures, I imagine you'd automatically round it up to 6.15, but languages might not do this unless they're explicitly told to. In C#, for example, the math.round function has a parameter for rounding mode, so you can decide exactly how you want to handle rounding. If I set the rounding mode to away from 0, I'd get 1.65, but if I set it to 2 even, I get 1.64. So it's best to do a little bit of digging on your specific language just to work out how it handles rounding. And finally we have truncation, which is simply the removing of a decimal part of a whole number. Unlike rounding, truncation never rounds up and always just leaves the whole part of a number. Some languages like C# offer this as an inbuilt function, but in other languages you might have to do this for yourself, so it's worth having a little look around and seeing exactly how your language handles it. So that wraps things up for this video. Of course, there are plenty of other arithmetic operators out there, but we've covered some of the main ones you're likely to come across today. We hope you found it useful. Thanks for listening.